In this video, we're going to talk about the formula for getting the least squares regression line. As you can see here, we have the formulas from page 172, which give us the slope and the intercept, which are the two things that make up the least squares regression line. So you see on the right here, we've got all these different things we're going to need, and they'll be given to you in the problem in order to actually solve this. So let's look at an example. Calculating the least squares regression line. It says refer to the data from the study of non-exercise activity and fat gain on page 164. You can look back and take a look at that example. But it says the mean and standard deviation of the 16 changes in NEA are, and they give us the X bar, the mean for X. They also give us the standard deviation, which is 257.66. And it says for the 15 fat gains, the mean standard deviation the mean and standard deviation for the Y value is 2.388 and 1.1389. Now already I'm noticing they give us the mean and standard deviation for both X and Y, and they actually give us the correlation. It's already calculated right there for us. So if you're given these 5 things, that kind of clues you into this is a type of problem where we're actually finding the least squares regression line with these formulas. So first, let's start with the slope. The book uses B for the slope. You may have used M in Algebra 1, and sometimes they use B for the slope and A for the y-intercept. Sometimes it's A for the slope and B for the y-intercept. So it kind of just depends on what book you're looking at or what formula or where you're getting your formula from. But just know that no matter what letter you use, it doesn't matter. The slope is always attached to the X. And so in this case, they give it B. But I know in the calculator sometimes we use A, and that's fine. No big deal. As long as you know the slope is attached to the X, it doesn't matter which letter we use. So the formula is the correlation, which is R, which is given to us, and then S sub Y over S sub X. That's our standard deviations of Y and X. And this is straight. Plug it into your calculator. Let your calculator do the work. So the R is right there. We're going to plug that in. So it's negative 0.7786. The standard deviation for Y goes on top. You can think of this as rise over run, or the change in Y over the change in X. It's kind of like that. So we've got standard deviation as Y is right here, 1.1389. And we're going to divide that by standard deviation of X, the 257.66. Now let your calculator do this. It does it very quickly. And we get a slope of negative 0.00344. That's our slope. So that's the coefficient of X, or goes in front of X. The next part is the y-intercept. And it's important you get the slope first because it's actually part of the formula. For the y-intercept, we've got our formula, which is A equals y bar minus B times x bar. Now, we just calculated this slope, which is the B, which is the slope at the front of x, and it's negative 0.00344. But you've got to be careful here because there's also a negative in front of that, so that's going to go right there. Don't forget that. And then the y bar is given to us in the problem. It's 2.388. And same thing with x bar. It's also given to us in the problem, which is 257.66. There we go. Now, be careful here because, like I said, there's 2 negatives in this problem. B was negative, and there's also a negative in the formula, so those are going to end up being added. Make sure you multiply those 2 first, then add on the 2.388, and we get a value of 3.505. It looks like. So putting the A and the B together, remember the formula for any line is y equals the slope times x plus the y-intercept. So to get the line of the, and I should put a hat there, to get the line of the least squares regression line, the formula is y hat equals, it's the slope times x plus the y-intercept 3.505. There is our final answer to get the least squares regression line.